Did you know that other more hospitable planets in the universe could support life? Earth is, as far as people are concerned, the ideal planet. We developed here, and natural selection ensured that we were well adapted to the environment, so this shouldn't be surprising. This is true for all species on Earth, at least until environmental circumstances alter and new adaptations are needed to ensure survival. Photosynthesizing creatures make up the largest majority of Earth's biomass, which is present in the planet's extensive biosphere. The area is also rich in flora and fauna. Therefore, we need to discover a location with even higher biomass and biodiversity if we are to search for a world that is more habitable than Earth. We refer to these worlds as superhabitable. Scientists have discovered new kinds of planets that may be just as habitable as Earth, if not more so. What are these planets? How soon can we go see them? Join us as we explore the planets even better for life than Earth, discovered by scientists. Earth is obviously the best planet for life out of all of the planets in the universe, right? Well, that's incorrect. Even though Earth is a wonderful planet, scientists have found a few that might be even more conducive to life. One located 3,000 light-years beyond our solar system currently holds the top place. It would seem that KOI 5715.01 satisfies the most fundamental need for life support. It is located in its star's Goldilocks zone. Therefore, the environment wouldn't be too hot or too cold for a vital component of life to survive on the surface. However, it would also fulfill a lot of requirements to be deemed superhabitable. According to some estimates, its parent planetary system is at least 5.5 billion years old, making it slightly older than our solar system by roughly 1 billion years. Furthermore, the planet would almost meet the required size. Researchers searched the galaxy for planets with masses up to 1.5 times that of the Earth in the hopes of finding habitable worlds beyond our own. Additionally, they ought to be around 10% bigger. This disparity in size would aid in the planet's heat retention. This exoplanet may have an even more diverse array of life forms if its average temperature was around 8 degrees Fahrenheit greater than Earth's. Well, KOI 5715.01 might somewhat exceed this criterion due to its nearly double Earth size. In any case, research shows that this planet is really colder than our own. Nonetheless, hope endures. A significant greenhouse effect could boost temperatures to the required level with the correct composition of the atmosphere. Furthermore, we've only scratched the surface of the superhabitable worlds. In addition, Kepler-69c is located about 2,700 light-years away. This super-Earth may be about 7 billion years old. This places it squarely inside the superhabitable planet age range of 5 to 8 billion years. Based on the 3.5 billion years it took for complex life to emerge on Earth, this range has been calculated. Therefore, a planet that is slightly older than Earth may have the best chance of containing life. This exoplanet alone might be just a touch too large to support superhabitation. Its mass is nearly 4 times greater than Earth's. This large stony planet might have a single enormous continent with enormous deserts in the middle. However, the coastline where Kepler's ocean washes up might be the ideal place for you to relocate. Kepler 1126b is the name of our next super-Earth, with the exception that it would be a little closer to home. This planet is part of a system that's 7.5 billion years old and is located approximately 2,073 light-years away. Like our own, it likewise revolves around a yellow dwarf star. The only star that's 2.5 times closer to its star than Earth is to the Sun is Kepler 1126b. Still, it's not a huge deal, since the orbit of the star is colder than our own. As a result, the range that is considered habitable would be somewhat closer to it. Moving on to Kepler 22b. The distance to Kepler 22b is 600 light-years. Though it is much bigger than the Earth, roughly 2.4 times larger, it was the first Kepler planet discovered in the habitable zone of its parent star. Could this super-Earth planet be solid, liquid, or gaseous? No one knows for sure. According to a recent study, the 290-day orbit of Kepler 22b is fairly comparable to Earth's 365-day orbit. Similar to our Sun, the exoplanet circles a smaller and cooler star in its G-class system. Furthermore, K2-18b is a planet that can be found in the habitable zone of the Leo constellation's red dwarf star K2-18. It was identified as a potentially habitable exoplanet in 2019 after being discovered in 2015 by NASA's Kepler mission. Because of its size, roughly twice that of Earth, and mass 8 times that of Earth, the planet was first categorized as a super-Earth. K2-18b is located a significant distance from Earth, about 124 light-years distance. It is known that the atmosphere of K2-18b contains water vapor. Water vapor was found in the planet's atmosphere in 2019 when researchers studied it with the Hubble Space Telescope. This discovery is noteworthy, since water is thought to be essential to life as we know it. The finding of water vapor suggests that liquid water might exist on the planet's surface, which is necessary for the emergence of life. Although K2-18b is thought to be a potentially habitable exoplanet, it's still unclear if life can exist there for humans. Based on estimates, the planet's surface temperature ranges from -99 to 117 degrees Fahrenheit. This temperature range is suitable for supporting liquid water, an essential element for life as we know it on Earth. Before deciding whether or not people could survive on the planet, however, a number of other criteria would need to be taken into account, including the planet's atmospheric composition, radiation levels, and the existence of other resources that are essential for survival. Astronomers and scientists continue to investigate K2-18b and other exoplanets through remote studies using telescopes like the Hubble Space Telescope and the James Webb Space Telescope, even though it is now not feasible to send a spaceship there. Perhaps in the future, technological and space exploration advancements will enable us to deploy spacecraft to exoplanets like K2-18b to investigate them closely and look for indications of life. This is still a long way off though, and will need major developments in other areas as well as space propulsion technology. If this proximity to a blazing hot star doesn't appeal to you, there is another super-Earth on our list. Additionally, it's a manageable drive from home. The distance to Speculos 2c is just 106 light-years. Not that it benefits in any way from its closeness. Traveling to this super-Earth would still take you well over 200,000 years, and that would be supposing you traveled at the peak velocity of NASA's Parker Solar Probe, the fastest spacecraft to date. Yet, Speculos 2c appears to be a potential option. It's a component of an approximately 7 billion-year-old system. Additionally, it might be a rocky planet similar to ours. Its red dwarf star is still somewhat tiny, even if it is located in a habitable zone. It's merely 15% the size of the Sun. This planet thus travels in a very tight orbit around its star. Given their near proximity, it's possible that Speculos 2c and its star are tidally locked. It takes this super-Earth 8.5 days to complete one orbit around its star and one full spin on its axis. This would result in perpetual daylight on one half of the Earth and perpetual darkness on the other. All of this suggests that life may exist in the narrow strip of land that separates these two sides, the Terminator Zone. To be certain, we merely need to take a closer look. Wouldn't it be good if the planets in our own solar system were a little more livable though, given how far away all these candidates are? We'll now move on to the Gliese 667cc. Gliese 667cc is 4.5 times as big as Earth and is just 22 light-years away from our planet. Although it only takes 28 days to complete one circle of its host star, the exoplanet is believed to be in the habitable zone because the star is a red dwarf that is significantly colder than the Sun. But Gliese 667cc, which was found in Chile using the 3.6-meter telescope of the European Southern Observatory, might orbit close enough to the red dwarf to be cooked by flares. Life there would undoubtedly differ from life on Earth if it existed. The sunshine is one significant difference. Roughly 90% of the light that reaches the planet comes from space, with nearly all of it falling within the infrared range. This implies that plants would be able to photosynthesize using more infrared range light than visible light, and that life there would have genetically evolved to see more in the infrared range. The rocky land masses and waters that make up the planet's surface are probably home to the planet's inhabitants. An intelligent species residing on the planet would have constructed much of its solar energy-dependent infrastructure, such as agriculture on the planet's sunny side, because it is tidally locked. The pull of gravity is another thing to think about in life. We would feel up to 1.6 times the weight of Earth, since the planet is more massive than Earth. The planet would also have a significantly heavier atmosphere than we are now accustomed to because of its enormous mass. Thus, life that developed on Gliese 667cc would be far better adapted to survive under these elevated stresses. There has been no confirmation of life there, although any such life would be very different from Earth's. In the future, we want to have a better understanding of the planet's surface and atmosphere through additional research, which will allow us to definitively determine whether or not the planet is habitable. Hopefully, future research will provide more details about the planet's surface and atmosphere, enabling us to definitively address the habitability debate. There are 2 other planets in the star's habitable zone, Gliese 667cf and CE, so even if we find that Gliese 667cc is inhabitable, we won't need to worry. Those are some of the closest known analogues to Earth, even though Earth 2.0 is still elusive. Well, we might find that as we explore space, there really is no place like home. Let us know what you think in the comment section below. Don't forget to subscribe to our channel and put on notifications for more videos. See you soon.